Alright, in this lesson we will continue working on our binomial distribution using the TI-30XS multiview to guide us. Alright, each child born to a particular set of parents has a 0.25 probability of having blood type O. Suppose these parents have 5 children. Let X equal the number of children who have blood type O. In that case, that means that X has the binomial distribution 5, 0.25. Give the probability and cumulative probability distribution for X. Verify that it is legitimate. Show your calculator setup, of course. So you should immediately create a table similar to this. Alright, just like this. So obviously this middle row here is going to be for our probability, and third row will be for our cumulative probability. Now, as far as finding these numbers, like I said, we're going to practice using the TI-30XS multiview, and we'll have to show the calculator setup. So first of all, we will type our X values into list 1 of our calculator. So turn on your calculator, fire it up. Okay, just to hit data to get to this area. If you hit data and 2, it will clear out anything that's in list 2. Now looking at list 1, I want it to be just 0, 1, 2, 3, 4, 5. So I've got 0, 1, 2, 3, 4, 5, and then it goes on from there. So I'm going to hit delete. Okay, so I've typed my X's into list 1. Now for list 2, we need a formula, okay? Now, if we were going to calculate this by hand and find the value, the probability of 0, this is what we would do. In fact, let me pick a random one actually, not 0. Okay, and keeping in mind, what do we have? We have 0.25. Okay, so remember that we have a binomial distribution with 5 outcomes and 25% probability of success. So we summarize that this way. Now, imagine that I wanted to just skip and find this one. Okay, of course, this is the probability that X equals 2. Imagine I wanted to skip to this. The way I would find that, if I were doing it one by one, is I would do start with the total. So I would do 5, choose. Now I want 2 successes, so that's 5, choose 2. Alright, in this case that's 2 kids with blood type O. Next come the probabilities. Probability of success and probability of failure. Okay, the probability of success, that's the one that they give us, 0.25. That means the probability of failure is going to be 0.75. Alright, 25% plus 75%, that's a total of 100. So if you need to, you can always get this by doing 1 minus the probability of success. Okay, but anyway, I'm going to assume you understand that for now. And the last thing you need are the powers. The exponent that goes on the probability of success is the number of successes. So that's 2. The power on the probability of failure is the number of failures. Now remember, this 5, which is this 5, represents the total number of trials. If the total is 5, if we have 2 successes, that means there will be 3 failures. Alright, these 2 have to add up to 5. And then we would just put this in our calculator. Okay, so let's just go back to a clear area. So I'm doing 5. I hit my probability button. second option, so I'm doing 5, choose 2. That's what we're working on. And then we have that probability of 0.25. Okay, again to the power of 2. These two numbers will always be the same, make sure they are. And then times the probability of failure, so 0.75. And the power is the number of failures, total of 5. That means 2 successes, 3 failures. And I hit enter. So that gives me 0.2637. Okay, so that's how we do it. Now, let's use this as a model to understand what I need to type into the calculator. This 2 is an x value. See? So, instead of putting 2, because this x value changes from problem to problem. X is 3, 4, 5. Okay, so I have to change the x value and put in a variable. Now the variable, because we're using the calculator, the variable is the location where the x's are, and they are in list 1. Okay, so that's why I'm going to put L1 everywhere my x's were before. And so this 2 up here, these are always the same. So once again, instead of putting second power, I'm going to put L1. Okay, list 1 is where my x's are. Now, this other exponent always depends on what came before it. So remember, the total is 5. Okay, and if we have this many successes, L1, if I want to know how many failures, well, it'll be the total minus L1, whatever that is. So this is the calculator setup. And this is what you need to type. Well, not type. Well, it is what we need to type in the calculator, but this is what you need to write down where it says calculator setup. Let's see, where does it say that? Oh yeah, here we go. So where it says calculator setup, this is what I'm looking for. Okay? Now let's go ahead and type this in the calculator. So what we need to do is we need list 2 to become our calculation. So we'll use a formula. So hit data. We need a formula. So arrow over there. Just hit enter. All right, and we're going to type in the formula that we just put on the paper. So open parentheses. We will do 5. Choose. All right, that's under the probability menu. So option number 2. So 5, choose. And remember, we want just a list 1. That's our variable. Okay, so 5, choose list 1. To get to list 1, just hit data and just hit enter. There's list 1. Close parentheses. Now we need our probability of success and our probability of failure. Probability of success was 0.25, remember, and we're going to do that to the L1 power. Okay, so I'm going to go caret L1. So again, I hit data and choose L1. Okay, so there's my one for the probability of success. Now for the probability of failure, the probability is 0.75. And remember, we have to do this to the power of 5 minus L1. That looks like a 4, doesn't it? It's going to bother me. 1. Okay, it's the total minus the successes. That'll be however many's left for failures. Okay, so I need to do to the power of 5 minus L1. Now here's the one thing you have to be careful of. Because this is a subtraction thing, it needs to be in parentheses. So 5 minus L1, so data L1. Okay, let me just scroll back through real quick. Yep, so that's how you type it in. You hit enter. And every one of these has been calculated for you, and all you have to do is copy them to your chart. Now let's check the one value that we did by hand. Okay, the probability that x is 2 should be 0.2637. 0.2637. So we know this is working out correctly. So that's a good habit to get into. Maybe do one of them by hand in the middle somewhere, and then make sure that when you type it in your calculator, you're getting the values that you know are correct. So I'm just going to copy these down one by one. So 0.2373. Okay, and I'll do the rest off camera. Alright, be careful with this fifth one. See how it says 9.8 E negative 4? Alright, that is your calculator's way of doing scientific notation. It's because it's a very small number and it's having trouble fitting everything. So this means, in scientific notation, it means 9.8 times 10 to the negative 4 power. Okay? Now, if you remember anything about scientific notation, if I was going to convert this to a regular number, you would know that this negative 4 tells me how many times to move the decimal point to the left. So that would be 1, 2, 3, 4. So the decimal point ends here. And then look at the zeros that we're going to have. So there would be a 0 here, here, and here. So this number is the same thing as 0.00098. Alright, so that's what this number is on your calculator, 0.00098. Now, we are rounding to the nearest 4 decimal places. So we're shooting for this many decimal places. Okay, but because this is an 8, this 9 has to round up to a 10. Okay, so what you're going to want to put in the spot down here is 0.0010. Okay, so just watch out for the scientific notation. Now, say if you got a number like this. I'm going to put an extra 0 in here. Say if it was 0.00098. Would I just put 0 here? Well, not quite, because we're trying to round to 4 decimal places. If the next number is 5 or higher, I have to round up. So if this was the case, I would put 0.0001. I would round that 0 up to a 1. On the other hand, if this was a 48, let's say, then that would round to 0.0000, and I would just put 0 in that case. Alright, just watch out for those. Alright, so just glance over your chart. This is what you should have for your probability distribution. Okay, please do not forget to show your calculator setup. Now, alright, it's time for the cumulative probability distribution. That's where we keep a running total as we go. We add up every probability along the way. So we're going to start off just zoom in a little bit. Well, the first one, all we have is the one probability, so we just copy that down. So 0.2373. Now, when we get to probability number 1, the cumulative probability will be the sum of both of these. Okay, so I'm just going to add those up. So that's going to be 0.2373 plus 0.3955. And that is 0.6328. Okay, and then we move on to the next one. Now for the next one, we want to have the total of all three of these again. Okay, now the 0.6328 is already the sum of all of these. Okay, we've already got the sum of all of those. So we really only need to add the third one. Okay, so basically we're going to do 0.6328 plus 0.2637. Okay, so that's 0.8965. Okay, and you just keep doing that over and over again. So we will wind up just adding these two and recording that here. Alright, that's 0.9844. Alright, and so when I get to the next one, I can take my previous total and just add the new one. So I'm just going to wind up adding these. And we get 0.9990. And last but not least, you'll take the total we have so far plus the new one. And that's going to be, and when you think about it, you knew what we would see. This is always going to be 1 unless we made a mistake, because this last one represents the sum of all the probabilities above. Alright, and of course we know they should add up to 1. So when we do the cumulative, it's going to start off small, but every time it's going to get bigger and bigger and bigger and bigger until it gets to 1 whole. So now we're supposed to construct a histogram of each distribution. So I'm going to do my my normal probability distribution here, histogram, and my cumulative distribution to the right. Okay, I noticed that my biggest number, you know, we're supposed to use the same scale, I do believe. So this goes all the way up to, you know, the equivalent of 100, you know, if this is like 1.00. So I need my scales to go up to 100 this time, so they can be on the same scale. Now, I mean, when I say 100, when I graph these things, I'm only looking at the first 2 digits, okay? So when I look at this, when I graph, I'm looking at 0.23, 0.39, 0.26, 0.08, 0.01, and 0. Okay, same thing down here, 0.23, 0.63, 0.89, 0.98. See how that's almost up to 100? And then 0.99, really that's basically 100, but then this one is the 100. So these are the numbers I'm comparing. So since I got to go up to 100, okay, I can do that if I do 0.20, 40, 60, 80, 100, okay? So I'll do that on both scales. So 0.20, 0.40, 0.60, 0.80, 1.0. Alright, same thing over here. 0.20, 0.40, 0.60, 0.80, 1.0. Okay, so that's a good scale to use. we're going from x values of 0 to 5. Yeah, 0 to 5. Okay, so I'll just do my 0, 1, 2, 3, 4, 5. All right, on both scales. 0, 1, 2, 3, 4, 5. Okay, so let's do the histogram. So this one, the first one is 0.23. All right, that's just a little bit above this. So it should be something like this. You know what, let me make this a little bigger. Okay. There we go. All right, so it should just be a little bit above. Okay, there's my first one. The next one is 0.39, so that's virtually 0.40. Okay, number 2 is 0.26. Okay, so that's going to be right about here. Alright, next is number 3. Number 3 is 0.08. Okay, that's pretty low. This is 0.20, so this is like 0.10. Alright, so 0.8 is going to be like down here. Okay, alright, remember this is 0.10 is right here in the middle. What's next? Number 4. So I have 0.01 and 0. So man, those are really small. Okay. So 0.01 would be like barely visible. It's like the thickness of the ink. And then 0, I just won't put anything. Okay, so there is my histogram. Okay. The shape of it, this particular one, would you say this is skewed left, or is it skewed right, or is it symmetric? Alright, I'm hoping that you see that this is skewed right. See how if it has a tail, the tail is going to the right? Look at the tail when you're judging how far it's skewed. Okay, now let's do our cumulative histogram. Alright, starts off at 0.23. Okay, this is going to be a little bit above, like this. Okay, and then the next one, alright, that was 0. So number 1 is at 0.63. Okay, so that's up about here, just a little bit above 0.60, 0.63. Okay, how about number 2? Alright, number 2 is 0.89. Okay, 0.89. Alright, so 80 is right here. 90 would be like in the middle, so 89 is going to be very close to being in the middle here, right? 80, 90, 89. Okay, so that'll be like this. Okay, that went over a little bit too far. Okay. Oh man, I gotta go to lunch. Let me just finish this up. Okay, and let's see, number 3 is 0.98. Okay, that's really, really close to 100 already, 98. Okay, so that's going to be like here. Okay, and then number 4 is 99. So just microscopically higher. All right, and then number 5 is 1.0. All right, it's 100%. Okay, so how do you think this one is skewed? All right, hopefully you can see that this is skewed to the left. Okay, now, do you think that cumulative, will it always be skewed to the left? Skewed left. Yes, it will, because cumulative is always building higher and higher and higher. So the fat end will always be on the right, and the small end, the tail, will always be on the left. So please understand that cumulative distributions will always be skewed to the left. Okay? So that's the main thing I wanted you to say right here. Cumulative distributions are always skewed left. Okay, normal probability distributions are, they tend to be a lot more symmetric, and although sometimes they can be skewed left or right. Okay, alright, I'm going to have to pause this video here for now and do the rest after lunch.